Back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 398, random pick index. Before we get into the question prompt, you guys know the drill. Please subscribe to the channel if you haven't already. It really helps me grow, and I want to reach 10,000 by the end of the year, so please help me with that goal. Anyway, given an integer array nums with possible duplicates, randomly output the index of a given target number. You can assume that the given target number must exist in the array. And we want to implement the solution class. And the solution object will be initialized with an array nums, and it has a pick method which takes a target and returns a random index I from nums, where nums of I equals to the target. So basically returns one of the indexes where that value, the value at that index is target. And if there's multiple valid indexes, then we should have an equal probability of returning one. So let's look at a example here where we have, our object, and we're given the values 1, 2, 3, 3, 3, and we are asked to basically pick a few values from there. And the way that we're going to solve this example is by the naive approach to the solution, which is not what your interviewer is looking for, although it is pretty intuitive, and that is the dictionary solution. So what we want to do is basically create a dictionary for each of the values, and we're going to map the indexes that we see it at, right? So 1 occurs at the 0th index, 2 occurs at the first index, and 3 now occurs at the 2nd, the 3rd, and the 4th index, right? So now when we're asked to actually pick a 3, we need to return one of these indexes, and it has to be at random. But since we have this list, we can just simply take one from here at random, right? We can just pick one, and all of them will have an equal probability of being picked. So it doesn't really matter what we return here as long as it's 2, 3, or 4. So that's fine, easy peasy. For the 1, there's only one thing we can choose from, so we just return the 0th index, and then we're asked to pick 3 again, and basically it's fine. We can just pick literally any one from here at random, and we're good to go. So this is really simple, it's really intuitive, but the problem here is that we actually need this extra dictionary. So this means that our space complexity is going to be big O of n, whereas the problem, what they want you to do is actually solve it using constant extra space. And you may be wondering, how the hell am I going to do that if I can't store the actual indices? And well, this is one of those questions where if you haven't seen the trick, you're probably not going to be able to solve it, which is probably why you're watching this video in the first place. But once you've seen it and you understand the trick, then it's super clear, and it's like one of those aha snaps, and you now understand it. And the way that we're actually going to solve this is by something called reservoir sampling. So let's actually clear all of this text here to give us some more room. And what we're going to do is we're actually going to walk you through how this solution is going to work in order to achieve that space complexity of big O of 1. And to be honest, when you see the solution and it clicks for you, it's kind of like magic. It's a really cool one. You're probably not going to come up with it on your own, hence why you're watching this video. So let's stop talking and talk about how we're going to do this thing called reservoir sampling. Okay. Welcome back. We've now cleared all of the extra text, and we can now talk about how to solve this using something called reservoir sampling. It's okay if you don't actually know what that is. Doesn't really matter. As long as you can solve the question, then you're good to go. Doesn't matter what it is in practice, we're just going to use it. So obviously, in order to get big O of 1 space, the easiest way would actually just be to do multiple loops through our array here, but obviously that's not great. Because we're gonna have, we could have potentially like a quadratic runtime, which is not good. So we want to be able to ideally do this in one pass through and with no extra space, which is basically what the interviewer is looking for. So what we're gonna do is we're going to go from left to right over the array. And we're gonna have a few variables to help us along the way. And we're gonna have a variable called count, which what count is going to represent is the number of times that we've actually seen the element that we're searching for. So for example, this 3, every time we see a 3, we're going to increment the count. Pretty straightforward. And we're also going to have a variable which is going to be called pick index. And this is going to represent the index that we've picked for this value, right? And we're initially going to set it equal to 0 because obviously we haven't picked any index. Now what we're going to do is we're going to go over our array here from left to right. And like I said, if we ever encounter the number that we're looking for, count is going to get incremented. So, we have our array 1, 2, 3, 3, 3. So let's kind of go through it and we'll go index by index. So first we're going to be here, is 1 equal to 3? It's not. So now we're going to go to the 2. Is 2 equal to 3? It's not. Okay, so now we go to the 3. Is 3 equal to 3? Yeah, so that's what we're looking for. So we're going to increment our count by 1. So it's now going to become 1. And here is where the magic happens. So let's think about this. If you have a bag, right? Let's say we have a bag and, okay, that's horrible. We'll say we have a box, right? And in that box, we're going to put some marbles into it. Now, if you have one marble in the box and you're asked to pick a marble at random, you're always going to pick that marble, right? There's only one marble in there. You put your hand in there and there's only a probability of 1, right? So, okay, but now, you add a second marble to the box. So now each marble now has a what? 1 out of 2 or 50% chance of being picked, right? 50%. And in the first case, it was 100%. And now if we add a third marble, it becomes what? 33%. 33 point, whatever, repeating, right? Percent that it gets picked. And same thing if we add a fourth marble here, it now becomes a 25% chance of being picked. Now, what do you notice about these denominators? Well, what you notice is that every time we see the value, we actually increase the count here. So, when we see the second one, it becomes 2. So now when we have 2 of them, each individual one has a 1 out of 2 chance of being picked. So what we can do here is we can actually update our pick index to be, whether or not it equals to the count, right? So what we're going to do is, because we can't store the actual indexes, what we're going to say is we're going to pick a random number between 1 and our count. And if this number actually equals to our count variable, then we're going to say that count is our random pick. And this is how we're actually going to achieve randomness here without actually needing to store the values. And let's kind of think about this and why it works and kind of think about our example. So in the first time that we see count, right, its initial count is going to be 0. We see the first 3 and count equals to 1. So we're going to do this and we're going to say our pick now is going to be the random choice. So we're going to take random of 1 to 1, right? Because count is 1. And is this going to equal our count, which is 1? So obviously, picking a number between 1 and 1 is always going to give 1 100% of the time. So in this case, we take our pick. Cool. So now our pick index is 1, because if we only see 1, 3 in here, then we should always, take that one index. But the tricky part is when there's multiple 3s. Okay, so now we're continuing. We get to the second 3. And now our count equals to 2. So now we want to update our pick, but only if it equals the count, right? So we're going to say we're going to take another random pick from 1 to the count, which is now 2. And if that number comes back and it equals the count, which in this case is 2, then we want to update our pick to be the index that we're currently at, which in this case is going to be the index. So this is 0, 1, 2, 3, so 3, right? And that's basically how we achieve the randomness every single time. And then again, when we get to the final 3, right, count now becomes 3. And again, we're going to take a random number between 1 and 3, because that's the new count. And if that value actually equals our count, which is 3 again, obviously that has a 1 in 3 probability of being picked, right? Because we have a probability of picking 1, which has a 1 in 3 chance. We have a probability of picking 2, which has a 1 in 3 chance. And obviously 3 has a 1 in 3 chance. So obviously you can see that each element has the equally, chance of being picked, which is what we want, given that the indexes are the same. So this is how essentially we're going to pull off our magic here. And if it hasn't clicked for you, watch it again and kind of think about this box example about how every time our probability increases, and this is directly proportional to the amount of marbles we had in the box, right? And you can think of the marbles as our like count variable here, right? And kind of once this all clicks for you and how this maintains the randomness, then this question becomes extremely trivial. But it is imperative that this part clicks for you. Otherwise, it's going to be very difficult for you to explain it. But essentially, this is how it works. The code for this is super simple, but if you don't understand why, picking the random value and then if it equals to count actually gives you that equal probability chance of being picked, then you're going to struggle here. So at this point, let's move to the code editor and actually write this up. It's like 15 lines of code, easy peasy. Okay, we're back in the code editor. Now let's type this up. So in our init function, we basically just need to store the nums that we're given. So we're going to say self.nums is going to equal to nums, if I could just spell. And now what we need to do is we actually need to go through our nums here from left to right. What we want to do is we want to keep track of the count, and we want to keep track of the picked index, right? And they're both going to be 0 at the beginning. So we're going to say for I num in enumerate self.nums. If I could again type today. What we're going to do now is we're going to say if the number equals to the target, then obviously our count increments by 1 because we've now seen our target. And now we want to say if random.randint from 1 to count actually equals to the count, we're going to say that our picked index is going to equal to I. And the last thing that we want to do is actually return the picked index. So let me just make sure I haven't made any syntax mistakes, and we are good to go to submit this. And actually, when we submit this, we're going to get a time limit exceeded for absolutely no reason other than Leetcode is terrible. And we'll see in a second that this is going to TLE, and it happened to me like a few minutes ago. So I don't know why Leetcode is doing this. If we look at my accepted solution from 2021, let's look at this one. It is okay. Literally the exact same code that we've written, right? Line by line, the exact same code. Same with my, whoops, where did it go? With my previous submission here back in, what is that? September of 2021. Again, we can see the exact same code. Actually, this way I did it with a default dictionary and it was accepted. So now even with the reservoir sampling, for some reason, it's not being accepted. Although you'll have to trust me that this is actually how you do it. If we even look at the solution here, let's see, reservoir sampling, yada, yada, yada. They do the exact same thing, right? They check whether or not the number equals to the target, they increment the count, and then they do a random integer. And again, they're returning the index. I mean, this one's in Java, but it's the same idea, right? For some reason, it's not being accepted, despite being the solution that Leetcode tells you to do. Something's going on in the back end. I don't know what it is. This is just to prove to you that this is the solution. Anyway, as you can see, the time and space complexity, it's going to be big O of n time because we have to go through the entirety of our nums here when we do the pick, and we're not using any extra space here for the pick, so it's just going to be big O of 1. So again, I don't know what is going on with Leetcode, why this is TLEing. It shouldn't. It was accepted in the past, but it is what it is. This is how you solve it. As you saw, even the official solution does the exact same thing. So I don't know what's going on. Anyway, so that's how you solve random pick index. The only tricky part here is really understanding why this actually gives you the randomness that you actually desire. And once this line here clicks for you, as it did, hopefully the box and marble example helped. If it didn't, maybe go rewatch it one more time, or maybe read through the discuss section for this problem, and hopefully that will help. Anyway, that's how you solve random pick index. One of those stupid questions where if you haven't seen it before, there's absolutely no way you're getting this solution before, unless you have like 200 IQ or something. You're probably going to solve it with the dictionary, and they're going to tell you, no, that's not going to happen. You need to do it better. So definitely one to know, because your interviewer is going to want this ridiculous solution that no one knows about. Anyway, that's enough of my rant. That's how you solve random pick index. If you enjoyed this video, please leave a like and a comment. It really helps with the YouTube algorithm. If you want to see more content like this, please subscribe to the channel. And otherwise, thank you so much for watching.